Hello everyone, my name is Sam Spade and welcome to another Coding Fundamentals in GML tutorial. In this tutorial, we're going to be talking about recursion. Recursion is a method of solving a problem where the solution depends upon solutions to smaller instances of the same problem. In programming, it essentially means when a function calls itself. Now that's not the only example of recursion, but that's the primary one, when a function calls itself. Recursion is not always an easy concept to understand, and there's a couple reasons for this, but the very core of it is actually quite easy. So here is a recursive function. We have a recursive function. We've named it recursive function, and all it does is call itself. So recursive function, the only code in it is calling itself. Now obviously this would be terrible code to write. It would just keep going and going until the program errored out. But this is the basics of recursion, a function calling itself. Now to make that useful, we normally want two other things. A base case where the function will terminate. Essentially, this is like the thing that will break you out of a while loop or a for loop or some other type of loop. You want to have a condition where the function will stop. The second thing that you would normally do, like we said, is the function would call itself, passing in a slightly smaller version of whatever information it received. And we'll see many examples of this. But this basic pattern of a base case and then calling itself with a slightly smaller version of itself are the two sort of fundamental ideas to get for writing a recursive function. At least most recursive functions. So here's a classic recursive function. Factorial of n. We have our base case here. If our argument equals 1, then we're going to return 1. And now we have our recursive function call where we're passing in the same information we received, argument 0, but a slightly smaller version of it, argument 0 minus 1. And we're actually going to step through this in the code, so I'm not going to go too in depth here. I just want to use it as an illustration for the last slide. Our base case, passing in a slightly smaller version of what we received. So now let's use a slightly more real world scenario. Let's say you want to add a group of numbers together by adding the first number to the sum of the rest, which really is how you add any group of numbers. So here we have an example of adding 1, 2, 3, and 4 together, and we would add 1 to the sum of 2, 3, and 4. Now we can't add all of these together at once, so we'll add 2 to the sum of 3 and 4, and then we can't add these together, so we'll add 3 and 4 together. Now we've added 3 and 4 together. We can say, okay, well this equals 7, so 2 plus 7 equals 9, and now we know that this is equal to 9. 1 plus 9 equals 10, and 1 plus 2 plus 3 plus 4 does in fact equal 10. Another way to look at the same problem, you could imagine that there are 3 people, and you give the first person this list of numbers, and they say, okay, well I can't add all of these together, so I'm going to take 1, and I'm going to rip off the part that has 2, 3, and 4, I'm going to hand that to the second person. That person looks at it and says, I can't add 2, 3, and 4, so I'm going to rip off the part with 2, and I'm going to give the part with 3 and 4 to the final person. The final person says, well, I can add 3 and 4 together, that equals 7. He reports to the person before him, who reports to the person before him, and the first person now says, okay, that's 1 plus 9, that's 10. So here I think we start seeing why recursion can be difficult, because if you try to hold all of that in your head at once, you try to get a full picture of that, it can be complicated. You've got to hold a bunch of different steps all at one time. And this is a simple problem. If you were to do this type of problem on a much larger number, there would be many, many steps. If you tried to hold all of that in your head at once, it would be very difficult. So here are some tips for making recursion a little bit easier. The first tip is don't try to hold the whole solution in your head. Look at it just part by part. Just that single instance of the person saying, okay, well, I can't add all of these numbers together, so I'll take the first number and I'll pass on the rest and I'll tell someone else to add all of those numbers together. And then every single person is doing that exact same step. I can't add all of these numbers together, so I'll take the first number and pass on the rest, and so on until you get to the final person and they add the last 2 numbers together and then they report back up the chain. The second tip is, at least occasionally, try to hold the whole solution in your head. And I know that contradicts the first bit of advice, but the more you do this, the easier it will get. You can work through some recursive problems on paper even, go step by step, work through them in the debugger, basically just getting a feel for how recursion works. And we'll talk more about this in part 2, but for the moment, let's switch over to GameMaker Studio 2 and see some examples. Okay, so the first function we're going to have is that recursive function. So recursive function, and I made a slight modification in it. So the recursive function, we're just going to take an argument. That argument is just going to be the number 0. And all it does is it shows the recursive call plus the number. Then it increases that number and calls itself again. And here you'll note that we don't have a base case. So this is never going to stop. But I wanted to show an example of what that would look like. So let's run it. Okay, so I'm not using the debugger here because I just want this to go, and you can see that our program is basically stuck on line 1. It's just calling this recursive function call over and over and over. The number's going up. We're already at 70,000 calls. We're right here in our code. We're just repeating ourselves over and over and over and over again because we don't have a base case. So I'm going to stop this now. Then I'm going to come over here and comment this out. We don't want an endless function call here. And now let's do the actual factorial. Okay, so we have our code here. We're going to pass in the factorial of 1 to demonstrate the base case. Come over here. You can see we've called factorial of 1. So does our argument equal 1? It does. That is our base case. So we will return 1. And the factorial of 1, here we go. The factorial of 1 is in fact 1. Now we're going to call in a factorial of 4. And you can see over here the call stack. Does it equal 1? No. So we're going to call it again with 1 less. So 4 minus 1 is 3. So now we're going to call this with 3. You can see it gets added up here, the same function call. It's not 1, so we go in. Now we can see our argument is 2. Does 2 equal 1? No. Does argument 0 equal 1? Yes, it does. We've got 4 things. So these are all stacking up. And now, and this is going to happen pretty fast, we're going to say, okay, return 1, and all the rest of the function calls are going to work. And you're going to see them pop off up there. There we go. They're all done. And factorial of 1 is now going to be 24. So the factorial of 4, so the factorial of 4 is equal to 24. All of those recursive function calls ran, and they added everything up, and indeed we get 24. So the next recursive function that we're going to look at is a little bit different. We're going to draw a fractal, but it's still going to be a recursive function call. So we're passing in some variables up here, and I'm renaming them. So we're going to pass in an x and a y and a radius. If the radius is less than or equal to 2, that's our base case we're going to exit. If we don't hit our base case, we're going to draw a circle, and then we're going to draw a circle to the left and to the right of that circle. Or really, we're going to call the recursive function call draw a circle to the left and right of that circle. And if we run this, and we're not going to do this in the debugger, because we just want to see what this looks like. So here we go. We've used a recursive function call to draw a bunch of circles, to draw a fractal pattern. As you can see, here is our first circle, or maybe it's actually a little bit hard to see, but you can see here is our first circle, and then this circle drew 2 circles, and then each of these 2 circles drew 2 circles to their side, and then each of those 2 circles drew 2 circles, and so on until we hit our base case where our radius is less than or equal to 2. So you can see that the way a recursive function call works is it calls itself, but the way that part calling itself works can be different depending upon what you're trying to do. In part 2, we'll look at flood fills, and we'll see how that works. But let's just do this one more time, and we'll draw it 3 times. Now we're drawing to the left, to the right, and to the bottom. And with that, we get this pattern, which I just did because I think it's cool. This you might recognize, in fact, as a Sierpinski triangle, where each triangle has a bunch of triangles inside of itself. In summary, recursion is a method of solving problems. Most commonly in computer programming, it is when a function calls itself. It requires a base case, so you don't have an endless loop. It requires something that stops the recursive function call. And then generally, it has some type of recursive function call, again, calling itself, but on a slightly smaller version of itself. And we'll go through some more examples and talk in greater depth about recursion in part 2. Now, like I said at the start, recursion can be one of the harder things to wrap your mind around. And sometimes I think it just helps to have it explained from a couple different angles or in a couple different ways. So I've got links to 2 other videos here, one by Computerphile, one by Coding Train. They're both in different languages, but the languages are similar enough to GameMaker Studio's language that you should be able to follow along. And I would highly recommend watching them for other explanations of recursion. Maybe just hearing it again will be helpful, or just hearing it in a different way will be helpful. As always, the links in this slide, as well as links to the slides and the source code themselves, will be below. And that's it. Thanks for watching.